All right, Unit 4 talks about trig functions. For section 1, we're just going to kind of first talk about angles. So I think you kind of already know what a regular angle looks like going this direction. So angles are usually going, I think counterclockwise, and then with there is another angle on this side. So if I told you that this angle here was 60 degrees, we already know a full circle makes 360. So if this is 60, then from here on back this way should be 300. So that makes 300 plus the 360 makes a full circle of 360. So this, yes, there we have we always usually talk about this angle here, but there's going to be other angles that we're going to be talking about that go clockwise, and those are the bigger angles. These are a couple of the symbols that you will see to represent angles: theta, pi, alpha, beta, sometimes capital letters, and X and Y. We're mainly going to be doing theta and capital letters for our angles, is what you're probably going to see the most in this class. But just in case, all these symbols represent angles, and you'll see it more once we get move further in the lesson. So just to kind of give you an example of some more angles, these again are the symbols. This right here represents the angle. So this angle of alpha is 75 degrees in 24 minutes. So we have one comma here for minutes, two commas here will represent seconds. So here's the 1 minute, the two little astros, whatever you call them up there, not semicolons, but y'all know what I'm talking about, will be seconds. So this 75 will represent this little part here. The beta will represent from here all the way from here. The theta represents all from here and so forth. So this is just other ways of looking at angles. And if you go backwards, so this angle here called phi goes backwards. That's why they have the little negative 90 degrees for this particular one. Coterminal angles, this is where we either going to add 360 or subtract 360 when we're trying to find the coterminal angle. So in the MyMathWise Plus, if it says find one positive angle and one negative angle, basically all you're doing is just adding 360 to the angle they give you and subtracting 360. This is pretty much the definition of what you need to do for coterminal. I think everybody kind of knows the quadrants. So if you have a X and Y platform, we have first quadrant, second quadrant, third quadrant, a fourth quadrant. Now going into angle conversions, a lot of this will be done on the calculator, and I have my calculator ready to go. Yeah, I have my calculator ready to go, so we can go over this part. But 360 degrees is the same thing as saying 2 pi in far as radians. So both of them kind of are equal to each other. And here are the little symbols. Second, I'm sorry, degrees, minutes, and radians, and we can get these little symbols by hitting second in the @ sign. So let me show you where this is. So if you hit second and the @ sign here, here is the degrees. This is going to be the minutes, and this is going to be the radians. We're also going to be using this one, and this is called decimal minutes and seconds when we convert for angles into degrees, minutes, and seconds, not decimals, degrees, minutes, and seconds. So a few examples, if you want to walk through, that's fine. If not, like I said, if I'm going too fast, you can always just come back to this video, pause it, and then do it yourself. But for the first one here, I'm going to first switch my calculator to degree. It's always tricky whether you leave it in radians or degree, but I'm going to go ahead and switch it to degree. And I'm going to go ahead and type in this first part here, and then I want to convert this part into a decimal. So this degree I want to convert to decimal. So the 50 degrees actually stays put as 50 because we're trying to convert this whole thing into a decimal degree. But we're going to change this back part here into this number here, which will represent the whole thing to be degrees. So in our calculator, we're going to type 50, go get the little degree sign. That was second apps. And I throw a little degree sign up there. Then it's 15. Go get the minutes, which is number 2. And the last one was 32 seconds. And this one here, you have to hit alpha and the plus sign because here it is in green here. And that gives us the seconds. All you have to do is hit enter. And you notice that we get 50.25. If you round this one, it'll probably be the 9. So 25, and here when we round it up to 9 on this part. So this is how you convert degrees with decimals. So radians is the same thing, but this time here we're going to use the R this time. So if I hit the pi symbol and then go get radians, which is number 3, you can hit 3 if you want to, hit enter, and then it changes to degrees for you as far as the answer is concerned. So 180 degrees gives you the pi radius. Like I said, for this one here, just do 1.96 radians and then hit enter, and then just like it says here, and it changes to here. So this time we're going to go convert to degrees, minutes, and with seconds. So this time we're going to put in 36.72 and then go get the degrees. So 36.72. Let me grab the degrees. And then we have to go grab now, because we're going to change it into degrees, minutes, and seconds. Go to number 4. And then it converts it back to what we have here. So just for a test, so you can actually see, I'm going to put it back to regular mode, because usually everything we work with is calculated is supposed to be in radian. And then I'm going to put in the previous answers. I'm hitting second enter to go back to get all the previous answers just to see if we get this answer here. And we actually do. So I'm thinking because we have the symbols here, the calculator recognizes this is degree and stuff, so we can kind of leave the mode in radians. But just to make sure, we'll go ahead and just test all of them out. So this is the pi one. Oh, so the radian one, if you're trying to convert to using the radian button, you see that you do not get the same answer. So I would say, just to be on the safe side, switch your calculator to degree so you won't be confused on when to go back and forth. So you go down to radian, hit enter, and then second mode, and then your calculator now is in the degree mode, so that way you don't have to worry about getting this kind of answer. If I hit pi radian, you get 180, which is the correct answer, but pi radian does not recognize that because the calculator was in radian and you want to be in degrees. So that part. So for these problems here, just remember to switch your calculator to degrees, and then once you finish converting on your converting, switch it back to radian for when you get out of this section. So let's do this one also. I'm gonna do 3 pi over 13 radian. So 3 pi divided by 13, and then we have to go get radian. So these are a lot of steps, a lot of back and forth you have to go. But once you do the MyMathFast Plus, you can you get more practice with it, and just continue practicing and looking at this video. You'll get the hang of it. Oh, I forgot to switch it to, got sidetracked. We're supposed to be changing it to degrees, minutes, and seconds. So make sure you tag that behind it. And then this is how we get this answer. Calculate mode. That's where's the okay, it didn't come out to be. I gotta put it in parentheses. So everything is real tricky. Let me throw these in parentheses first. So it's good now that we actually get all these little nooks and crannies on the video so you can remember. So obviously, if you do not put the parentheses around the fraction 3 power over 13, you see what kind of answer you get, which is incorrect. So the parentheses must happen in order to get the correct answer. And if I round this up, it'll be 18.6. So this is another thing that you need to don't be concerned yourself with, even though it's going to be 18.6. This will be actually 18.5. If you're off about, a few decimals, please don't worry yourself with that. This is the most important thing, that you know how to make sure you put the parentheses around it, switch it to the DMS, and then get this kind of an answer. If you run into a lot of these problems on the test or something like that, I will give you points back if you just a few decimals off. So that's not what I'm really testing you on. So just don't concern yourself with that. So let's move on to the next part. So section 2, we're going to be defining trigonometric functions. So if we have a triangle within a triangle, so we have a big triangle. So here's my big triangle. And then we have another triangle inside, like so. These triangles are considered to be similar, and because they're similar, the angles are going to be equal to each other, and the ratio of the lines will also be, the proportion of them will be equal to each other. So obviously the angle A for ADE and the angle for CAB are going to be exactly equal to each other, just like angle B and D is equal to each other. And then angle C and E are going to be equal to each other. So AB, which is here, over AD, so we have the bigger one over the shorter one as a proportion, is going to be equal to the same thing if I do AC over AE. So these two here. So you'll need this when solving different equations, especially when you have two triangles, especially word problems when you have two triangles inside of each other. So the next part that I want you to, this is going to be one of the most important ones that you have to either memorize or put like on a little note card for your test, is what sine is equal to. Sine is y over r, and I'll explain this in a minute. Cosine, x over r. Tangent, y over x. Cosecant, r over y. Secant, r over x. And cotangent, x over y, which is the same thing as saying opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and so forth. As you can see, for the relationship between the two, the sine is the same thing as saying cosecant, but it's flipped. So if I have y over r, well, it's going to be r over y for cosecant. So sine and cosecant goes together. Secant and cosine goes together. Remember, it's just flipped. And then tangent and cotangent is also flipped also. Then they have they go with each other. So it's kind of written down here: cosecant with sine, secant with cosine, cotangent with tangent. So looking at here, where did the y and the x and all the r's come from? So if we have a triangle, here's my x-axis, here's my y-axis. If I have a triangle, we already know the x-axis run this way, y's run up and down. So the x and y come from these sides of the triangle. Here makes the 90-degree angle for a right triangle. So the r will always be your hypotenuse. So anything opposite the right angle, 90 degrees, is going to be considered to be our r, which is the same thing as saying hypotenuse. As you can see, r equals hypotenuse, and so forth. Now, opposite and adjacent. So those come from what it determines what angle we actually are talking about. So if we're talking about this one here, this y is considered to be the opposites because it's the opposite of it. The x represents the adjacent part. Adjacent means side by side. So here is the adjacent. I guess it looks better right here. So here is the opposite side, and here down here will be the adjacent side. And again, if you make a right angle, this here would be the hypotenuse. So this is where the O, H, and A all comes from. So here's an example I drew out. So this case here, here's my right angle. So this here represents the r, which is the square root of 10. Down here, from here to here is 1. So x, remember in the ordered pair, the first term is always going to be x. The second term is always going to be y. So x and y. So here's my x, here's my y. And then how do we get to this square root of 10? Here's a Pythagorean theorem. Remember, Pythagorean theorem always deals with right angles. So if you have a right triangle, you can find the other side using the Pythagorean theorem. So a equals 1, 3 equals b, 1 squared plus 3 squared. So 1 squared is 1 plus 3 squared, which is 9. 1 plus 9 is 10. In order to get rid of this square, you have to take the square root of both sides. So that's why the square root of 10 came about, and we throw it over here to our hypotenuse. So 1, 3, hypotenuse. So remember what sine is equal to. Sine is equal to y over r. So going up here, which one represents y? The 3 over r, which is the hypotenuse, so y over r. Cosine equals x over r. So here's my x, and here's going to be my r. So basically, just kind of looking, once you have all three sides, you can just pretty much say, if I say find the sine of for this triangle, you just say y over x. I'm sorry, y over r, and so forth. Tangent is going to be, looking at tangent, is y over x. So here's my y over x, which is equal to 3. So remember the relationship between the two. Secant goes with here, cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Remember, all we're doing is flipping it. So if I have 3 over square root of 10, I flip it 10 over the square root of, square root of 10 over 3. And so forth, going forward, just flip them, and that's going to be our answer for if I ask you for cotangent, secant, and so forth. So for this one here, it probably looks better if I show you the blank one. And I'll open this one up too so you can see it. So this is what a problem looks like for here. I'm only giving you 12 and 13 for the problem. Cosine is going to be 12. I'm sorry, 12 over 13. So here we actually have to make a triangle, fill in the missing parts, and use the SOHCAHTOA. That's just kind of what it means. Sine over opposite over hypotenuse, cosine over adjacent hypotenuse, and tangent over opposite over adjacent. Is easy way to remember is SOHCAHTOA. So how do we get these parts here? The rest of the parts? Well, 12 was, if we're talking about this angle here, and we're talking about cosine, remember cosine deals with x over r. So opposite over hypotenuse. So because this is located on the bottom, that's going to be our hypotenuse, which is here. And the adjacent is going to be the 12, which represents here. So how do we get 5? Again, use the Pythagorean theorem. 12 squared, and then you find 13 squared. I think this is 169. And then we do 144. Take it over by subtracting. We get 25. Take the square root of both sides. That's how I got 5 here to figure out my missing angle. So that's the missing part here is the 5. So once we have all the parts here, remember, just go back up to your notes up here and just place everything in a fraction. So y over the r, and here cotangent. Remember what tangent is? Tangent is actually y over x. So if I do y over the x is 5 over 2. Remember, cotangent, we have to flip it. So that's why we get 12 over 5. So just go back and kind of review all these these answers to make sure you understand where all the parts came from. Same thing here. If I'm giving you in the directions here, all I gave you for here on on the directions is the cotangent of 0.2554. Well, how do you make this into a fraction? We can put this over what? We can put it over 1. So if we put it over 1, and we're talking about cotangent, so the 1 represents the y, and the decimal number represents x. So the 1 represents the y going up and down. The 0.254 represents the x. And how do we get this part? You just do the Pythagorean theorem. This squared plus this squared, add them together, take the square root of both sides, and here is the missing side, which now we can put together and then get this answer. 1 divided by this part gives us this, this divided by this gives us this, and so forth. So you really need to understand the Pythagorean theorem to find missing angles, and you also need to kind of know this part here, SOHCAHTOA y over r, so you can put them into the fractions like we did here. Here's a good chart that you can that it's going to be helpful. The fraction ones are pretty straightforward. 1 over 2, 2. It gets a little difficult when we have the square root because the calculator won't give us the answer for square root. So if I did sine 30, we get 0.5. We hit math fraction. You already kind of know that's 1/2, but this is where the 1/2 comes in the play for there. But if you do cosine, you get a weird decimal. But this is actually saying the square root of 3 divided by 2. And this is the answer here. So this is where this chart kind of helps us explain where everything came from. And you can also get it by just kind of doing it yourself, doing a Pythagorean theorem, and getting this answer, the square root of 3. So this will be my C, these will be my A and B, and it kind of gives you the 6th trigonal function for 30. For the next part here, we're going to be using a calculator to find the following. This is pretty much straightforward. All you have to do is just pretty much put this in your calculator. So just to kind of give you to show you what I'm talking about, sine 13.5, and you get 0.233, which is the answer here, 0.2334. So once again, because the calculator is in mode already in degree, you probably don't need to put the degree sign because the calculator already knows, since it's in mode, that this is a degree, so you don't have to go get this. But if you had to put it in, if you put the mode in radian, this is where it gets a little tricky because obviously the calculator does not represent this is actually a degree. So this is where you're going to have to go get the degree sign, and then it kind of recognizes it. So you just kind of play around as far as what is easier for you, just to leave it in degree mode. But like I said, it doesn't hurt. Even if it's in degree mode and you put the degree, you're still going to get the right answer. But this section should not be difficult. We're just putting this in and getting the answer, putting this in and getting the answer here. If you're doing cosecant and secant, remember these little techniques here. You have to put cosecant is 1 over sine and then the angle, wherever it is, to get this answer. So you do have to put it over, put the 1 on top in this on the denominator. If we're trying to find an angle, one of the good things you need to write down is anytime you need to find an angle, you need to do the inverse. So the inverse is located on your calculator. If you hit second in any one of these buttons, you get the inverse. So if I hit second and cosine, you get the inverse. This is anytime the direction says find the angle. You're going to need to figure out, you need to do the second and then whatever it is, and you have to do the inverse. That's going to be pretty much a given for every problem. So to kind of see what it looks like on my MathFast Plus, this is what it's going to look like. You're given a sine theta like so, and then the fine is here. The reason why we do the inverse on both sides, because the inverse of this sine cancels both of these out, leaving us just with theta. That's actually what we're looking for, find theta. So if you do the inverse sine of this part and inverse sine and over here to both sides, just like if you take the square root of both sides, if you add to both sides, subtract to both sides, you always got to do everything to both sides. Take the inverse, these cancel, leaving you with just theta, inverse over here, and it gives you this answer like so. So let me write down. So just to kind of let you see it again. So 0.4571, we drop it here, and that's where we get the 27.20 around the 2 decimal places. So we have the 0.20 here. So once again, this part should be okay too. Just remember, if you're trying to, if it's asking for an angle, do the inverse. So the tricky part about this part though is just when we get into cosecant, secant, and cotangent, because you still do the sine inverse, but remember that fraction that we discussed before. You have to take this part here, put it into a fraction, 1 over, 1 over, 1 over, just like here, and then do the inverse to get your angles for it. So cosecant, secant, and cotangent is the tricky part to these parts. So this is just more examples that you can follow. This solution is available for you. So if the direction says find sine, if we're given the secant of this one, first of all, we have to convert it to the degrees, and then we have to throw it into the sine button to get the actual decimal degree. So we do the inverse cosine first, because we got to get rid of this secant part first. So inverse cosine, remember the 1 over this number, get our answer, and then you put the answer, which this is our theta, in for here, and you put sine of theta equals this part. So it's kind of like a 2-part problem. You got to get rid of the secant first, get rid of the sine first, get rid of the cosine first, by just giving us a theta, get our theta answers, and plug it into the first part of it like so. The right angles here, again, we're going to be using a combination of the SOHCAHTOA, and we're going to be using a combination of the Pythagorean theorem. And if you remember, all the angles inside of a triangle equals 180 degrees. So just another example of what the problem will look like. I'm only giving you A is equal to 150 and C is equal to 345. These are the only 2 parts I'm giving you in the problem. So the directions want you to find all the missing parts. That means there is a B angle is missing, a B side is missing, and all the angles are missing in this problem. So the best thing we want to do is, since we have our A and C, put it in the Pythagorean theorem to find out our B. Then that way we have all the sides. So 150, 345, and then the B equals to 310.7. To find the angles, you just kind of pick an angle that you want to kind of search for. If you choose that you want to find this one first, again, it does not matter which one you choose. But if you choose to find this one, I'm going to do the opposite over the hypotenuse. That's what sine is, SOHCAHTOA. Opposite over the hypotenuse. So the A is 150 over the hypotenuse, which is 345. Now, I did tell you that it does not matter. You could actually use the B also, but the best way to get your answer like fully right is to always use the answers that they give you, because even if you use B, we don't know if this is actually the right answer. We hope you did the math right to get this answer. But if you try to use cosine and you did the adjacent over the hypotenuse, you're doing this one over here, which will give you the right answer if you did this part right. So I think it's always best to just use the answers that's given to you. Then you know when you come down to do the math, this answer will be correct. So this answer is 25.77 degrees. We already know what C is because this is a right triangle. This has to be 90. This is 25.77. We know all three angles must add up to equal 180. So 180 minus this part minus 90 gives us the 64.23. This one here, I gave you just the angle and just the one of the sides. So for this one here, it'll probably be easier for us just to figure out what the other angle is, because if B is equal to up here 32.10, we already know what C is equal to. We can kind of guess what the A is going to be equal to by just doing the three angles equal to 180. So once again, to use the information given to you, the B, if I use sine B, what is sine supposed to be? Opposite over the hypotenuse. So the opposite one that was given to us, put this on top, and then this provides us with this part here. So let me help you solve this part here. We got to solve for C on this part. So if you want to write down this problem here, and we're going to use our calculators to figure out the C part for this problem. So because C is located on the bottom, it's probably a rule that you probably want to write down. If you're trying to find the C on the bottom, we're always doing whatever this is divided by this part. Because if I multiply both sides by C, that cancels out this C. And then we take this part over to this side, we have this over here. So anytime you find the bottom part of a fraction, we're going to do whatever the numerator is divided by all this. So let's go ahead and put this in the calculator because we're looking for 1.227. So 0.625 divided by sine and this is how we get the answer, 1.227. I think I have an example of the one of it being on top. Here it is. So we have one on top. You're trying to find the missing one on top for this one here. We're just pretty much taking this one and multiplying on both sides to find A. So if I multiply this side by 0.0875, that cancels with this one. So that cancels, that cancels. Do it over here. I'm left with just A. So multiply these two together here. So if it's on top, we're going to multiply the bottom one to here. If we're trying to find the bottom part here, we're going to take this part here and divide it to whatever the numerator is. So those are two quick little tricks that you might want to jot down to make when we solve it all, when you get it set up and it's time to solve. That's just more examples. In the lab, we're going to have and when you do the lab 2 and begin that, you're going to have to read this word problem, the 7 word problems, and set up your triangle like so, and then solve for each one of them. So for this one here, the key word in this one is angle of elevation. Angle of elevation means if I'm elevating, I'm going up. So this is why the angle is on the bottom. If I'm going down, depression, then the angle is usually on the top. I'm looking down. But angle of elevation, I'm looking up. So the 4 degrees go here. The downstream of the small boat traveling this way, we need to figure out how high the falls is now. The Niagara Falls is. So this is like the waterfall, the boat going. I'm looking up at the waterfall in slide 4. So if I'm having this part, this part, and this part, what I'm going to use tangent, because I don't have anything about this angle here. What is this angle called again? Hypotenuse, because it's the right angle here. So if I go back up, sorry, I got to scroll back up, but this is the only way I can show you. If you look at all these parts, sine deals with hypotenuse, cosine deals with hypotenuse, So these two actually doesn't really do me any good to use the sine or cosine because we don't have anything, we don't have any information about the hypotenuse. So opposite or adjacent is the one we're using, and we're going to be using tangent. So here is the opposite over the adjacent. So if this is my angle, the opposite, which goes on top, over the adjacent, what goes on the bottom. Remember, if we're trying to solve, if it's on the bottom, remember what we do to both sides. We multiply. So if it's on the bottom, multiply this one time here and get this number here. So just to kind of give you another quick example on the calculator, 2500 times tangent of 4 degrees. I'm gonna get my buttons right sooner or later. Okay. Oh goodness, it went over here. So 174.8, and then I don't know if yeah, it does match it exactly. So again, reading the problem and setting it up. Again, the x is on the bottom, so remember, take this number here, and we're going to bring this underneath and divide it underneath. So 325 divided by this, because this time the missing part was in the denominator. And no, as you see this example, all your problems is not going to be tangent. It just happened to work out that way, and most of all answers will be working out will be tangent, but you should get at least maybe a few that you have to use a different one. And this one here, for the example, the angle of depression is 42 degrees. So if you're looking here and looking down at an angle 42, if you add both of them together, that makes a perfectly right angle. Now, back in unit 3, opposite angles are equal to each other. So if you still want to stay consistent using the elevation, if this angle here is 42, then that means this angle here is also 42. So anytime you see angle of depression and you put this angle on the outside, just know the opposite angle over here was actually going to be equal to each other. So it really doesn't matter which one you use. You can use the 48 or you can use the 42. Just if you use the 48 one, this is where we put the one on the bottom. So again, to get this other angle, they did the 90 degrees, subtract it to get 31.5. To put cosine here, it's on the bottom. Make sure you take this part and divide it here. So just you can review the rest of these examples. Remember just to try to read the word problem and kind of set up the way it needs to be set up and then answer the questions. I think the last thing I wanted to kind of go over is the resulted force of a tree. This is where we're going to be using R. Again, this is the same thing as using Pythagorean theorem to figure out the missing part of the R. So this is 10, that's 4. This is the hypotenuse. You put it into the formula, the Pythagorean theorem, the formula, and get this part to get our R. Then use the inverse tangent to find the angle. Same thing here. So once you figure out the missing part, this is the angle, this is the angle, this is the 90 degrees. So we're trying to find the hypotenuse here, get our R, that's what's equal to this part, and then we use the inverse tangent to locate the angle.